I've condensed a full year of truly mind melting consciousness conversations with the greatest scientists in the world into just 42 minutes. Expect to learn why Anil Seth thinks reality is a controlled hallucination, how Peter Godfrey Smith and Nick Lane think animals might have first evolved experience, and some of Michael Levin's most wonderful and truly radical ideas in all of biology. Here are the top 5 consciousness clips on the Giant Shoulder 2025.
How does our brain hallucinate our conscious experience?
That's a good question to start with. The reason I use the term hallucinate, I actually use the term controlled hallucination. I think the control is just as important as the hallucination. Otherwise, you get into all kinds of tangles and end up saying things like the world doesn't exist or that everything we experience is made up. And it's a metaphor, and like all kind of linguistic metaphors, it's useful but also potentially misleading. What it points to is this claim about how conscious perception works. And this claim has a very long history, and it goes back to Plato, goes back to Immanuel Kant in philosophy, goes back to Helmholtz in psychology and physiology. And the basic idea is very simple. The basic idea is that the brain has no direct access to the world or the body. It's locked away inside this bony skull. And so it has to make an inference about what's out there on the basis of the sensory signals that it gets, the sensory signals that come in through the eyes and the ears. You know, they're only indirectly related to what's out there in the world. They're noisy, they're ambiguous, they're uncertain, they're unlabeled. So the idea is the brain is doing something like Bayesian inference. It's saying, okay, here's what I believe now about the state of the world and the body, and here's some new data, so how should I update what I believe now on the basis of this new data? And there are 2 claims here. The first claim is that the brain does this by continually generating predictions about the sensory data that it's expecting to get in levels across this hierarchies in the brain. And sensory input in this view isn't something that's read out by the brain. It's rather prediction error. It's the difference between what the brain expects and what it gets. And so the brain uses sensory data to keep its predictions tied to the world. And in doing this, it can sort of solve this problem, at least approximately, of Bayesian inference, of inferring in a best guess the most likely causes of sensory signals. So that's kind of a claim about the mechanism in the brain. And the second claim, at least for me, is that what we consciously experience is not a readout of the sensory signals. It is rather the content of the brain's predictions. So it's sort of coming from the inside out, calibrated by the outside-in sensory signals. And that's why I use the term controlled hallucination, because it connotes something like experience being internally generated, but controlled by sensory signals from the world and the body.
It's such a cool idea. I think it's one of the most profound ideas I've ever read about or come across in neuroscience, is this idea of perception. Do you think, can we know if there are any senses or aspects of our conscious experience that are more hallucinated than others? Like, is our vision more hallucinated than our auditory perception or our interoception or all of the other senses that we'll get into?
That's a good question. I don't know if it's easy to characterize things that way. There's a constantly shifting balance even within a given perceptual modality. So when you pay attention to something in vision, for instance, you really like focus on it, even if you're not looking straight at it, you might focus on something in your mind. What's happening there, or at least what people think is happening there, is that your brain is rather placing extra weight on the sensory signals rather than on the predictions. So in that sense, you might say your perceptual best guess becomes a little more tightly controlled by the world and a little less hallucinatory.
Right.
But in another sense, all of your experience is always all hallucinatory, because that's kind of the core claim, that what your experience is the top-down prediction. It's not the bottom-up sensory signal. But the degree to which the bottom-up sensory signals affect the top-down predictions, that can change. Whether there's like systematic differences across different perceptual modalities, I don't know. There certainly could be between people. So when people actually have the kind of hallucinations that we commonly use the word for, maybe they have schizophrenia, maybe they have other conditions that lead them to have experiences which kind of lose their grip on the world and the body in some significant way, well, then it's reasonable to say that they are hallucinating more than other people because their perceptual inferences become less controlled by the world and the body.
Right. What is it about our peripheral vision that seems to make bad predictions more often? So one example of this that I always have is that I'm walking down a busy street and I will glance and I will so frequently think that I see famous athletes on the street. You know, like the amount of time when I moved to Barcelona, I was like, that's definitely Messi. That's definitely, and it will always be at a glance. And then I'll look back at them and I'll just realize that there was, you know, a Messi-shaped person, or like
what's a Messi-shaped person? Like somebody...
generic brown hair, white, small, 5'8", wearing an Argentina jersey, maybe. You know, exactly. I was going to ask that. I'm kind of curious, like, what are the features in the brain as well that it's really integrating to make this prediction? Like, is there hundreds? Is, you know?
Well, were you ever right? Was it ever Messi or was it never Messi?
Not yet. But I'm still combing the streets of Barcelona to find him someday.
Oh, but he's in isn't he in Miami now? Anyway,
he's in Miami at the moment. Unfortunately, he left a few months after I arrived. But for some reason, interestingly enough, my predictive model hasn't updated that information.
Right.
Or maybe it has. I can't tell.
No, but that raises an interesting point, right? Because you so strongly associate Messi with Barcelona,
yes,
that even though you know on some level that he's not there, your brain is still expecting it to be the case at some level, right? And this is interesting because there are some visual phenomena that, however much you know about them, you still can't help seeing them in a particular way, and we call these visual illusions cognitively impenetrable. So a classic example is something like the Muller-Lyer illusion. These two lines which are the same length, you can measure them, you can know that they're the same length, but they will always look different. So you seem to have a kind of cognitively impenetrable Messi illusion, which is, I haven't heard of that before.
I've heard you talk on podcasts that you're working on your own theory of consciousness. I know we're not going to get to all of it, but can I convince you to drop a few little hints or a few little tidbits of what your theory of consciousness really involves?
Well, I can talk about what we are doing that bears on it. It's not the actual theory isn't nearly ready yet to say anything strong. But here's one thing I can say. Both Anil and Peter and a lot of folks in the field, some of the most radical ones extend sort of down into insects and things like this, and then there's a community in the diverse intelligence field. There's a community that will go to plants and single cells. František Baluska and Pamela Line and so on will go to bacteria and single cell and plants. There's a great community working on plant intelligence and all that. I am sort of way more radical than this, because I don't actually think there's anything. If you want that spectrum to stop somewhere, you have to specify what the secret sauce is. What is the special thing? And I don't think it's the material. I don't think there's anything special about being proteinaceous. I don't think that it's the origin story. I don't think there's any magic in having derived from a random meanderings of mutation and selection. I don't think that's necessary for making minds. I think it's much more basic than that. And I catch flack from that community too by putting what they call machines on that same spectrum. So it's really quite disturbing. So my framework is disturbing on both ends. The sort of mechanist molecular biology folks say, well, this is really bad. You're bringing some sort of cognition into molecular events, things that should be the province of chemistry. And I say, but we've shown Pavlovian conditioning in molecular networks. Like it's the same, it's the same stuff. But anyway, but they want to keep it to chemistry. And then on the other end, you have people who in the organicist tradition who have said, look, we've for hundreds of years we've fought against the mechanization of life, the reduction of life to simple machines, and now you're putting these machines on the same spectrum as you're going to devalue basically the whole majesty of living minds. I think it's all a spectrum, and they're on the same spectrum, and here's why. What I found is that in very simple systems, and I'll tell you briefly what they are, but very simple systems that are in no way alive, that are not evolved, that are not that are actually deterministic, you already get the kind of surprising behaviors, and in fact, some behaviors you would recognize as cognitive capacities. You already get that, and what I claim is that for the exact same reasons that the laws of chemistry don't tell the whole story of, let's say, a human mind, the laws of computer science, meaning algorithms, the description of algorithms and the materials, don't actually tell the whole story of even very simple machines. This magic that we're talking about, this ability to have goals and cognitive properties that are not prescribed by the physics of your organism nor by the materials, but seem to be something more than that. That's real. I think that's absolutely real, but it's not limited to living things. It emerges extremely early in the kind of ladder of complexity. You don't need to be complex. And to kind of nail this down in the most disruptive way possible, I took the most the simplest thing I could think of, which is sorting algorithms. So like bubble sort, like these are very simple algorithms, 6 lines of code, completely deterministic. People have they're designed to sort arrays of numbers from a jumbled up mess into a sequence of numbers. And so this is the work of Taining Zhang and Adam Goldstein, 2 of my students. What we basically did, these algorithms have been studied by generations of computer science students. Everybody studies them for 60 years or more. And nobody noticed the following thing: that if you look at them in a particular way, if you actually treat them as potential agents, which doesn't look like they are because it's just 6 lines of deterministic code, how much agency could it have? If you actually are willing to suspend your armchair beliefs about it and actually do experiments and actually see, well, what is this thing capable of? What you find out is that same algorithm, that exact same algorithm, it sorts numbers, all right, but at the same time, it does some other stuff that is nowhere in the algorithm. And it has these little side quests, these weird little side quests that it does while it's doing that. And I think it's an extremely minimal model of what we see in life, which is, you're subject to the laws of physics and chemistry, and you can't do anything that is disallowed in the laws of physics and chemistry. And yet you will do things that, while not prohibited by those laws, are neither prescribed by them. And that degree of, people call it emergence, and I don't like that word at all. And so I have a whole other framework for thinking about them that's very Platonist, kind of like Platonist mathematics and so on. We can talk about that separately, which is then this is going to get to the theory of consciousness, because I don't think we make minds. I don't think we create consciousness. I don't think we do it when we make an embryo. I don't think we do it when we make an AI or an embedded robotic system. I think we facilitate the ingression of certain patterns from that Platonic space. And this is where we get to a completely, sort of different theory of consciousness. Because, and the reason I can talk about this now where I couldn't before is precisely because of the xenobots and the anthrobots. It's because typically when you have, in biology, when you have any kind of an animal or a plant, you say, well, what explains the shape and the behavior that it has? The standard answer is evolution, a history of selection. It was selected to be this or that. Well, anthrobots, there's never been any anthrobots. There's never been selection to be a good xenobot. Where did their shape and behaviors come from? And that leads to a deep question of, where do mathematical truths come from? Where do forms come from? Things that are not dependent on the physical world, that you could change anything you wanted in the physical universe. You could not change the value of E or the shape of certain, fractal structures or whatever. There's nothing you can do in the physical world to change that. So that eventually that gives you the flavor of what's going on. But the idea is that magic that we associate with cognition, with freedom, with open-endedness, it doesn't take life, it doesn't take cells, it doesn't take minds, or it doesn't take brains or neurons or anything like that. It is baked into the most simple elements of the universe.
That is radical. I cannot wait until you have that fully packed into a book or a paper or something. I can't wait.
if I could leave with one final question, Mike, it's been so much fun. I think I could talk to you for 1,000 hours and still not even be remotely bored. You're an incredible scientific speaker and just mind, and it's a privilege to be able to talk to you.
I appreciate it very much. Thank you.
Is there any part of the scientific work that you've done that you're scared of? That you're in the back of your mind, you're kind of fearful of where it could evolve, where it could go to, or what it might look like in 10 years, 20 years, 50 years?
There are two things. The thing that I'm scared of all the time is the failure to live up to the potential of regenerative medicine. So it's not, I think when people always ask about, ethical implications, I think they're typically thinking about it in this way. Everything's cool. Everything's good now. And you scientists better not screw it up. So what are you afraid of that's going to happen? I go in the opposite direction. I say, look around. Things are absolutely not cool. I get email. I'm not even a clinician. I get emails every day from people in the most incredible medical suffering. The environment is a mess. All of these things, inaction and the inability to learn what we need to learn to elevate and enable people to have the embodiment that they want, right, is I think would be a huge moral lapse. I think we have an ethical responsibility to get these things to the point where everybody can have the embodiment that they want and are not subject to the winds of cosmic rays that hit their embryonic cells when they were an embryo. And so that's the first thing. So the fear of not living up to that, I think, is absolutely real. And the other thing is there's some issues, not particularly of my work, but the ability to recognize other minds that are not like ours means that we have to radically redo our ethics. And that, I mean, that's not just me. That's not my work in particular. It's the fact that when you make tools to see that, my God, there are other intelligences that we never recognized before. That's a major responsibility, and that's scary.
So you have these three groups where there's evidence for pain, there's behavioral complexity, there's navigation and learning and targeted motion and so on. And within their different styles, I think in each of those three groups, one of the things that's happened is the evolution of subjectivity in a strong sense of that term, the evolution of a perspective, a point of view, an orientation to the world. That evolutionary process, I think, is roughly speaking a consequence of the evolution of agency. Action, agency, behavior is part of the animal way of being, and it's especially refined and developed in those three groups. But if you're going to have coherent agency, I think subjectivity comes along with that. You start to be a system to whom things seem a certain way. You become a center of converging sensory lines, and you become the initiator of outward causal lines in behavior. So part of the story I would tell in terms of the special properties of subjectivity as an evolutionary product, and one that makes sense in the context of the evolution of agency. And the other part of the story, the second part of the story, involves peculiarities of nervous systems themselves. I think that there's reasonable evidence, or it's far from a crazy view, that the peculiar properties of nervous systems, of that kind of biological machinery, have something important to do with the formation or the creation of subjective experience. I understand that you had Anil Seth on the podcast not that long ago. So Anil and I are kind of in the same camp on some issues, including the importance of the biology, basically, the importance of the peculiarities of nervous systems. And we both think that arguments that became influential in the late 20th century and that still have a lot of influence, that suggests that the hardware doesn't matter, that ordinary computer hardware would be fine if you just programmed it in the right way. You could get a sentient and experiencing system that way. We both don't believe that. We both think that nervous systems are probably important for somewhat different reasons. In my case, the thing I would point to as potentially important and as a kind of bridge between the biological and the experiential is the combination in nervous systems of point-to-point networked influences. This neuron makes that neuron fire, and so on. And more diffuse, large-scale dynamic patterns that involve electrical oscillation at a slower pace, below the threshold of neural firing, large scale in the sense of unifying the activity of much or all of the brain, the kind of thing seen in EEG recordings, basically. Now, in adventurous parts of neuroscience, gamma waves in the brain have for a while, fast 40 hertz, 40 cycles per second waves have for a while been thought to have some association with conscious experience, especially on the perceptual side. People like Wolf Singer, Lucia Maloney, Francis Crick, and Christoph Koch has changed his mind a bit, but he was in this camp for a good while, have thought that the kind of unification that those large-scale dynamic patterns in the brains, those large-scale dynamic patterns give to the brain is important in explaining experience, where it's the unified features of experience that have an explanatory connection, perhaps, to these features of brains. So, some decades ago now, Wolf Singer and others suggested that the binding of features in experience, the fact that you see shapes tied to colors in objects in experience, that might be explained in part in terms of the coordinating role of these large-scale electrical patterns. There's some work by Brynne van Swinderen at the University of Queensland who does fruit fly work. This is flies, not even bees, pretty small nervous system, where there are beta range oscillations in the fruit fly brain that seem to have some association with attention in a fly. And it's also well known that those oscillatory patterns are important in sleep, in anesthesia, in all sorts of consciousness-related stuff. So I would suggest that, to put it in a somewhat compact and really, not much detail way, that the basis for conscious experience, for felt experience in animals, is the combination of a collection of features that give you subjectivity in a strong sense, that make you a subject, to whom things happen, something that has a centered perspective, all that kind of stuff. There's a set of subjectivity related features that are fairly schematic and that come from the evolution of agency. And then there's the weird properties of those control systems that we ended up with in our heads, nervous systems, brains. And there, I think the combination of those point-to-point influences, the more familiar network-based features of neural activity, and the more diffuse, large-scale oscillatory patterns. It's something about that combination I think is very important in explaining experience.
Awesome. That was so well explained. I love hearing you talk about this.
It struck me for a long time that the depolarization of a neuron giving rise to feelings of things. So the hard problem, it's usually called the idea of qualia, of feelings, that we feel something. Why would potassium ions or sodium ions or calcium ions coming into a cell give rise to a feeling of anything at all? What is a feeling in physical terms? And again, I think a lot of people back away as soon as you start asking those questions because it feels like it's not really science.
Yes.
But at the same time, I think most biologists would agree that the feelings are real, which is to say they're not a complete fabrication. They're something that we can see in animals. We can see in ourselves. We can tell, we understand our own emotions from within. So I think most people would agree that they're real. And if they're real, I think most people would agree, again, that they evolved by natural selection. We primarily have feelings about ourselves in relation to the environment. are we good or are we bad, or how are we doing here? We're not primarily conscious of the movements of the stars or the heavens or of celestial beings, or we're conscious that we've got tummy ache or whatever it might be. It's very physical, and it's very much about organism in an environment. So it's about the organisms. It evolved by selection. I don't think many biologists would disagree with that. They're real and therefore physical. And if they're physical, we should be able to measure them. And if we can't measure them, then we have a problem. And I don't think that there's anything that we know about neural nets or the function of the mind that explains why this pattern of neural firing is associated with conscious awareness, and this very similar pattern of neural firing is unconscious or subconscious or whatever it may be.
Yes.
It seems to be the wrong level of analysis. We don't seem to be able to distinguish between different types of network at the network level. And when I come back to thinking about bacterial cells, which I'm far more comfortable with now, and I think, okay, I've got a cell, it's an oblong, it's got metabolism in it. Outside, we've got an environment. The environment is harsh in this way. It perturbs metabolism in that way. Metabolism is now not generating a membrane potential in the same way, and that's giving me a kind of an integrated feedback on my position in relation to the world. Is that what a feeling is?
Yeah.
In physical terms, is it something to do with the electrical charges on the membrane being modulated, possibly something to do with electromagnetic fields as well, in the sense that the charge is being produced by the movement of charge. So we have an electrostatic charge across the membrane being generated by movement of charge, movement of electrons, movement of protons, and so on, in pretty strictly defined ways. So there's a lot of information that you have in those about your state in relation to the world. So why would that give you useful information? I think it would give you useful information because if the whole thing was automated, and you respond to your environment by changing your phosphorylation state, by changing your gene expression, by upregulating chaperone proteins in a stress response, whatever it may be. So you're responding automatically to your change in state. How do you know whether that's going to be good enough or not? Should you have stayed or should you have gone?
Right.
And as soon as you start changing those things, you're no longer in the state that you were before. You're now in a different state. So have I done enough? Do I need to keep doing more? When do I stop? And how far have I come already if I can't remember the previous state that I was in? So you're messing up the situation all the time by changing in response to it. And so if you want to know how am I doing right now, you kind of need to have an immediate answer. Like, it doesn't have to be a perfect answer. It needs to be an approximate answer. I'm okay, stay, or I'm no good, go. In which case, a certain membrane potential is giving you that information before you've had a chance to respond to your environment internally. And if you can do something about it, like move, power up your flagellum, which is proton powered, by the way, and paddle over there, then you've got agency. You've sensed your environment. You had a physical response at the level of membrane potential that tells you how your metabolism is in relation to that environment before you had time to do anything about it. And that said, oh dear, power up the flagellum and paddle over there. So that state, that membrane potential, the electrical charges seem to give you this information and could potentially be the physical states that we associate with feelings. Obviously, they're hugely embellished in the central nervous system, and yes. I'm not trying to explain everything here. It's just what is the physical basis underpinning it. It seems to me to relate to metabolism and charge and fields and those kind of things. And another kind of really interesting and important thing then about that is it relates to the wetware of metabolism. It relates to the survival of organisms. It relates to integrating your state in relation to the environment in terms of your wetware. And so an AI, even if it's even if it's robotic and self-aware and all of those things, is not necessarily going to have, it's a very different substrate. It's not necessarily going to have feelings in the way that I suspect animals would.
So then would you be comfortable in saying that bacteria are maybe not conscious in the same way that we are? They're definitely not conscious to the same extent, but there is, you know, it's a spectrum of consciousness, and it's about how much consciousness, and they likely do have some subjective experience of what it is like to be that bacteria, even though to the human brain we can't empathize with that, we can't understand that, but it's likely that that's the case.
I don't imagine that they would have any self-awareness as such. The problem with consciousness is this, it means all things to all people.
Yeah.
And I'm not talking about consciousness in any way that most people would understand it as relating to a human being. But is there a kind of a quantum of a feeling in a bacterial cell trying to integrate its state in relation to the environment as a readout of your metabolic wetware, as a charge and movement of charge on a membrane? Yes, I think that they would have feelings in that sense. And it may be as simple as good or bad, go or stay. I don't really subscribe to the idea that the universe is conscious to the kind of panpsychism ideas. I tend to think of it as primarily as a process of life, of living things, and dependent on the substrate of living things, so the wetware of metabolism and so on. But then you're still faced with this question of what does it do and what's it for and how does it get selected? And my answer to those is that, well, it's about trying to understand how you're doing in relation to the environment through a single readout that tells you immediately I'm doing well or I'm doing badly, which is a physical state of charge and fields associated with that charge. I don't know how cells are picking up on that and responding to that. It's not that I've not got an answer to half of the questions that these raise. But I think that way of thinking about it has the potential to say, well, here is the minimum possible imaginable feeling, I'm good or I'm bad. Here's what it is physically. Here's how it becomes incorporated into a more complex cell. Here's how you end up in the central nervous system and so on. And underneath it all, there has to be some correlation between what the organs are telling you about your state and your actual state. Just as with perception of a tree or a lion or whatever it may be, there is, even though we're projecting it and we're trying to conjure our understanding of the world into existence by projecting it out into the environment, we have an input of photons, we have an input of sound and whatever it is, and there's some objective basis, even if it's a very flawed objective basis. There is an input that we need to interpret, but it was a physical input.
Yes.
And I think feelings in that sense are a physical interoceptive input about the status of the organisms grounded in the metabolism of those organs. And then the question is, how does the system know how those organs are doing? What was the readout that said my kidneys are in trouble here, as it feeds back somehow to the central nervous system?
I think that the fundamental form of consciousness is affective consciousness. Raw feeling is the ground zero of what consciousness is, and it is our point of entry into understanding what consciousness is. I think is this fact that the brain mechanisms that wake the brain up, the brain mechanisms that render our cognitive and perceptual machinery conscious, are brain stem mechanisms, and they are also mechanisms which are demonstrably generative of intense affective states. When I say demonstrably generative of them, let me just point out the obvious. Number one, you stimulate those structures, deep brain stimulation of the periaqueductal gray or of various reticular activating nuclei. It produces the most intense and the widest range of affective states. If these structures were merely regulators of some kind of quantitative level of wakefulness, then you would expect if you stimulate those structures, you'd get more or less aroused. But what happens is that there are very intense fears or rages or depressions or orgasms, intense affects are generated by stimulating those structures, the very same structures that underpin wakefulness. And, which is a highly neglected fact, the mainstream of psychopharmacology, in other words, the mainstream of neurochemical substances that we use to treat emotional disorders, they are the neuromodulators that are sourced in the reticular activating system. So serotonin, dopamine, noradrenaline, and of course histamine and acetylcholine, they're not so central in psychopharmacology, but serotonin, noradrenaline, dopamine, these are all sourced in the reticular activating system, and these are the brain chemicals that psychiatrists tinker with, not anesthetists, psychiatrists. So what I'm saying is that this part of the brain, which is clearly a prerequisite font of all consciousness. There's no such thing as cortical consciousness without it being activated from the upper brainstem. There's no form of cognition or perception that can be conscious unless it is modulated by these upper brainstem arousal structures. So this is these structures which generate consciousness in general, which generate dreaming too. These structures are affective structures. And I think that that's a very important fact in terms of understanding what consciousness is, what it's for, what it does.
It might be useful to give a quick definition of affect, because this is a word that if you're not a consciousness researcher, you don't use all the time. So I'm curious, can you just define affect? Because we're going to use that word a lot for the rest of the podcast.
Okay, so I'll tell you, first of all, what everyone will agree with. When I say everyone, I mean everyone in the science of affect. Because like in every branch of science, there are things that people disagree about. But what we all agree about is that affect has a property, a unique property, which is that it's valenced. In other words, it has a goodness and a badness that is intrinsic to the, it's not, you can't say red is intrinsically good and blue is intrinsically bad. So perceptual qualities are neutral, but affective qualities are valenced. They have an intrinsic goodness or badness about them. Pain just is bad. Thirst just is bad. Hunger just is bad, etc. And the relief of pain and of thirst, the quenching of thirst and the satisfying of hunger is just good intrinsically. So affect is valence. That's what we all agree about. The second thing that surprisingly everyone in affective science agrees about is that it is a state of arousal. Affect is measured on, it's either a depressing of arousal or an exciting of arousal. So it's a state which has both valence and arousal. Now, some people, this is where the disagreements arise. Some people say that those are the only properties of affect, that it is both valenced and arousal. By the way, let me say again, perceptual stimuli are not intrinsically increasing or decreasing of arousal. To the extent that they increase or decrease arousal, to that extent they have triggered affects. That affect has been enlisted by or triggered by the perceptual or cognitive process. Now, what I think we absolutely need to add to that definition of affect as being both valenced state of arousal is that it has intrinsic categorical qualities. In other words, the badness of sleepiness is not the same thing as the badness of thirst, is not the same thing as the badness of pain, etc. That affects have an intrinsic qualitative nature that distinguishes one affect from another. So I don't think there's a thing called affect that doesn't have a quality, that you can't feel bad without that badness being about something, a certain kind of a badness. Rather, I should rather put it that way. Now that's moot. Some rather senior affective researchers don't think that affects are intrinsically qualitatively differentiated from each other, but I think that they are. In other words, I don't think that there's a common denominator. This is why I think it's so important. You know, if you say I've got 8 out of 10 of sleepiness plus 8 out of 10 of thirst, that gives me, 16 out of 20 of negative affect. All I need to do is sleep, and then I'll be fine. It's not true. You know, if you only sleep and don't drink, you're going to die. So I think that the fact that affects are treated as qualitatively distinctive categories. I mean, that's what categorical variables are in their essential. The essential meaning of the term categorical variable is that they are qualitatively distinguished from each other. They're not reducible to a continuous quantity. And I think I actually think that's the ground zero of qualia. I think the fact that they must be treated as categorical variables for the reason that I just said is why they have quality. This is a fundamental feature of consciousness, that it is qualitative.